Welcome to Notes 4. We are going to be studying correlation and regression in Unit 2, and here is a list of vocabulary words. In class, we'll go through and describe them and talk about them a little bit further. I'm going to encourage you to pause the video and read that along on your own if you did miss class. There are also some pictures that describe correlation coefficient visually as well. So let's go ahead and start off right here. The first thing that we're going to calculate or look at after you've paused the video and looked at all of that on your own is the correlation coefficient. With the correlation coefficient, we're actually looking at a numerical value. We're going to calculate a numerical value that describes the relationship between two variables. We're only going to be looking at simple relationships after all. Now, from -1 to 0 and 1, and I actually drew a different kind of picture in class, but the closer it is to 1 and -1, the stronger the relationship. +1, -1, identical as far as the strength of them. Now, I think in class gave a -0.6 to a +0.6 to describe a weak and actually a non-existent relationship if it fell on 0. But just to help with the words, a relationship with a correlation coefficient closer to 1 or -1 is considered a strong relationship. So we will highlight that in green. This is strong. The yellow, that's weaker, to the point of 0, where 0 actually describes no relationship. And you'll see that again when we look at our hypothesis test. And again, we will go over this in depth in class, but this is certainly a nice preview. We will be calculating the coefficient of determination. Now, here's our first data set. And I actually like to encourage you to build everything in columns. On your homework, you'll also be building the columns yourself. First thing I'm going to do is read, and it says a manager wishes to find out whether there is a relationship between the number of radio ads aired per week and the amount of sales, Y, in thousands of dollars of a product. Before we do anything, I want you to go ahead and build the two columns. I need one for ads and I need one for sales, where X was the ads and Y was the sales. We're going to list that information. Each one of these actually gives us a data pair. This data comes in points or pairs. In a minute, after I show you the columns that you'll need to build, you're going to need to stop the video and build those columns on your own. You also want to total them all. All right? You're going to want to come up with an X times Y column. That just means multiply each X times its corresponding Y. You're going to need to build an X squared column and a Y squared column. That means square each X. And you're going to find a total for each of these three columns. Go ahead and pause the video, and when you finish building it, we'll continue. All right, after you've built and summed those columns, and you'll do it for every exercise on your homework, the very first thing that they ask us to do is to draw a scatter plot for the data, and then to describe whether we think there's going to be a linear correlation and why. So let's do that first. We're going to need an x-axis for the ads and a y-axis for the sales in thousands of dollars. Now, the units do not have to be the same on the x and y-axis. For instance, on the ads, here it's 2 to 12, so I'm going to use units of 2. Same units, I'm going to use the same units for sales, but those are actually in thousands, aren't they? 2,000, 4,000, 6,000, 8,000, and 10,000. Now plot each one of these points. This is what I was talking about with data pairs. This one has 6 data pairs, so our n is going to be 6. 2, 2, 5, 4, 8, 7, and 8, 6, 10, 9, and 12, 10. Now, definitely based on everything we talked about in class, that is excuse me. All right, based on everything we talked about in class, that is definitely it is indicating a strong relationship because the points are pretty well lined up. It doesn't matter if they're going upward or downward. Remember, positive 1 and negative 1 are both perfect or very, very strong relationships. And even though we don't expect ours to be perfect, very strong would be closer to 1 or closer to negative 1. This does indicate, based on what we talked about in class, a strong relationship. It also indicates a positive relationship because from left to right, the points do have an upward trend. Now, first thing I'm going to have you calculate after that in part B is to find the correlation coefficient and run a test of the hypothesis. You will need table I at your disposal. That was handed out in class. If you missed class, it is in the tables folder on Blackboard. All right, let's calculate our correlation coefficient first. Here's the formula, and we already have all of our columns built. I really just want to be able to show you how I plug into it, so I want to write it down. The most interesting part is the fact that the denominator has a giant square root in it, but the square root actually has 2 brackets inside. And again, this is on the formula sheet that was provided for you in class. If you missed, it is on Blackboard. Now, let's go ahead and plug in. N is the number of data pairs, the sum of x, y, 338, sum of x times the sum of y, all over a square root of, and in the first bracket, 6 times 401 minus 45 squared. In the second bracket, 6 times 286 minus 38 squared. Again, in class, we'll go over how to put that into your calculator. Otherwise, come and see me or visit with the tutor. Once you calculate that, you are going to get 0.988, and that goes right along with our prediction. We predicted strong and positive, and that is definitely strong. It is very close to 1, and it is positive because, well, it's a positive number. So it does confirm what we thought. It is strong and positive, so I'm feeling really good about this. The next thing that they ask us to do is to run a test of the hypothesis. H sub 0, H sub 1, critical value, obtained value, and conclusion. This is at the top of this is on your formula sheet as well. Or I'm sorry, it's not on the formula sheet. We went over it in class, but yours will look identical every single time. The correlation coefficient or rho is equal to 0, not equal to 0 in our H sub 1 or the alternative hypothesis. The CV comes from our table. We will use the N that we have on this particular test. N is 6. And on our table, in order to use table I, we have to use degrees of freedom, or N minus 2. That's actually on the table. We always use alpha, or a level of significance of 5% as indicated on our question. So you're going to use 6 as our N, that's 4 degrees of freedom, and our alpha is 0.05, and that'll give us a critical value of plus and minus 0.811. That critical value is used on our table to help us make a decision. Our tests, as we discussed, are all two-tailed tests. The positive critical value goes on the right. The negative version of it goes on the left. Remember, the acceptance region is this open area between those two values. The shaded area on either side are our critical regions and our rejection regions. Now, the obtained value is the value that we got by computing the correlation coefficient, the 0.988. When I plot that on my graph, it falls right here. Because it fell in the rejection region, I'm going to say reject H sub 0. Because we're rejecting the H sub 0, that means I agree with this one. Now, we talked about the fact that rho, or the Greek letter version of R, the correlation coefficient equaling 0, means that there is no relationship. So if I don't agree with him, I'm agreeing with the opposite. That means that there is one. And luckily, we've already talked about and twice confirmed that this one has a strong positive relationship. So you will write, there is a strong positive relationship between the number of ads and amount in sales, in thousands, of course. And that's it. Oh, sales generated. All right. And real quick, on or letter C, they do want us to compute the coefficient of determination and give an interpretation. So let's do that. The coefficient of determination is R squared. So we're going to take the 0.988 squared that we got, 0.976. And the way you interpret that, that means that 97.6% of the variability of the data in this study is due to the number of ads. There's also a coefficient of non-determination, and that is 1 minus R squared, or really 1 minus what we got there. So it ends up being 0.024, or I can interpret it this way. Now, I don't ever ask for this one, but what you actually found was that 2.4% of variability is due to other variables. I'll see you in the next video.